You should be fine. Wow, for number 6. Okay? So, when we add or subtract, we have to have a common denominator. Okay? So the first thing we do for the addition and subtraction ones is try to factor the denominators. Will either of those denominators factor? No. Okay? So, if you can't factor them, you write both of them down as the common denominator. Both of them. Okay? So we need x minus 3 and x minus 5. Okay? If we could factor either one. Once we have it factored, whatever factors show up, you write down. If a factor shows up more than once, you don't have to write it down more than once. Just one time is fine, but you gotta. So usually we're going to have 2 binomials. That's going to be our common denominator. Okay. The original numerator was 2x for this one and 3x for this one. Okay. Since I changed the denominator from x minus 3 to x minus 3 times x minus 5, I have to do the same thing to the numerator. I multiplied the x minus 3 by x minus 5. I have to do that to the top as well. The exact same thing. Here I already had the x minus 5. I multiplied by x minus 3 to get from here to here, so I multiply the 3x by x minus 3. So that's what those 2 fractions look like now. Any questions? Okay. Now before I can subtract the 2 equations, or the 2 fractions, I have to distribute. So my denominators won't change. Once I got the common denominator, it just stays. Don't change that at all. But you distribute. So this 2x times x becomes 2x squared. And the 2x times negative 5 becomes negative 10x. And the 3x times x is 3x squared. And the 3x times negative 3 is negative 9x. So we just distributed there. You guys know how to do that. So now I can subtract. Okay? So I go 2x squared minus 3x squared is a negative 1x squared. And again, my denominator stays. Right? And then negative 10x. And here's where a lot of kids make mistakes. What's minus a negative? That's plus, right? So this is negative 10x plus 9x, which is negative 1x. Questions? Now, at this point, okay, again, for 5 and 6, don't do any factoring of the numerators until you get to this point, until you add or until you subtract. Once you get it down to 1 fraction, then we're going to try to factor the numerator, and they both have a negative 1x in them, the GCF. So I'm going to pull it out. And when I divide this by negative 1x, I get x, and this by negative 1x, I get 1. Sometimes this factor, one of these factors will match one of these, and then you'll have to simplify it. In this problem, it didn't match. Nothing matched. So either numerator is acceptable. Okay? This over that, or you could use that over that. But I would always check this, because sometimes you can simplify. Number 5, actually, after we add them, we can simplify the fraction. And we'll go over that here in a few minutes. Questions on that? Does that make sense? Does that help in that type of problem? Liam?
Is that how you use is the negative 1x, x plus 1 over x minus 3?
Yeah, either way. You can leave that on the top over this or this one? Because you saw that it did nothing cancel. Yeah, so usually I'll leave it in factored form because I'll go ahead and do that. Sometimes you won't be able to factor it, so you just whatever it was over your denominator. Any other questions on that? Okay. So, number one. Okay, for the 1, 2, 3, and 4, you're going to factor everything you can factor before you start canceling. Okay, don't start canceling right away. Factor everything that can be factored first, tops and bottoms. 1, 2, 3, and 4. Okay? So for number 1, we got x squared minus 2x minus 3. And x squared plus 5x plus 4. Okay, so again, I go in my head through those steps factoring we've been doing here for a few weeks. Look for a GCF. Look for a difference of squares. Look for a sum or difference of cubes. Look for a special trinomial, regular trinomial, grouping. That's what we go through in our head, or what I do. Hopefully you have started to do that. Okay, but there's no GCF for either one of those. It's got 3 terms, so it's not number 2 or 3, because those are only 2-term problems. So this doesn't have both positive perfect squares, so this is an easy one. Again, when A is 1, like both of these, all you got to do is look at the factors of the third one, the C. Only way to get x squared is x times x. And you're just looking at factors of -3 that add up to -2. Okay? Which are -3 and +1, right? Any questions on that one? Now this one, they're both positive perfect squares, so I could do my 1, 2, 3 test. Remember, number 1 is the square root of that, which would be x. And number 2 is the square root of that, which is 2, and then number 3, you're supposed to multiply those. Is that half the middle? 2x half of 5x? No, so it's not one of those special ones. But you could check that. But even if you don't think about checking that, which you really don't have to, you'll still get the answer doing it as a regular trinomial. So really don't even worry about that. But I just wanted to remind you that you could do that. All right, again, A is 1, so it's just x times x to get x squared. Now I'm looking for factors of 4 that add up to 5. Well, I got 2 times 2 or 1 times 4? What's it going to be? 1 times 4, right? 1 times 4 is 4, 1 plus 4 is 5. Remember, when the third term is positive like this one, both binomials are going to have that sign between them. So they both have plus. So I see in the top an x plus 1 and 1 in the bottom. So those cancel, and my answer is x minus 3 over x plus 4. We've just simplified that fraction. Right. So again, 1, 2, 3, and 4, factor everything that can be factored first. Number 2, we got 5x cubed over 10x squared plus 5x. Can I factor the numerator? A 1-term polynomial, a monomial? You can't factor that. It's just already a factor, right? Binomial. Is there a DCF? Yeah. What is it? Whoa. So the top we couldn't do anything to start, but the bottom has a 5x or GCF, and then we get 10x squared divided by 5x is 2x, and 5x divided by 5x is 1. So we factor it. Can't go any further factoring. So now I look at top and bottom. Do I see common factors now? Yeah, I see a 5. Cancel. And I got an X here and 3 X's up here. What happens? That cancels and leaves me 2 of them, right? So my answer is X squared over 2X plus 1. Question? Simple, right? You can do it, no problem. Factor everything you can first. The only thing we can factor this time was the denominator. But then we saw we had 5s top and bottom and an X top and bottom as factors. So we could do some canceling of factors. Number 3. Mr. Myers.
Yes.
Can you factor anything now?
Oh, X squared minus 9.
All right, go ahead.
So that would be X plus 3 and X minus 3. And you can cancel.
Let's slow down for a second. That's right, that's a difference of squares. These two couldn't factor. All right. Anything else I can factor?
2X minus 4.
Yeah, the 2X minus 4. What's the DCF? 2. All right, so go ahead with canceling, you said. Cancel what?
X plus 3.
X plus 3, yeah. Anything else? No. They're close, aren't they? X plus 2 and X minus 2. They gotta be exactly the same. So you can't. So I have a 2 and an X minus 2 up top. And on the bottom, I've got an X plus 2 and an X minus 3. So factored everything we could. Then we canceled common factors. But remember, one's got to be top and bottom to cancel. Not side by side. One in the top, one in the bottom. You okay with that one? Okay. Number 4 is a division problem. Now, what do we do with division problems? Change them to multiplication, right? So I'm going to write it down as the multiplication problem. What do we do to the second one? Flip it, right? Reciprocal. Right, Chris? And Chris? Got 2 Chris's. Remember to flip. Okay? So once we've got it flipped, and as a multiplication problem, we're going to do what we've been doing. We're going to factor everything that we can factor. Michael Waltz. How do you factor this first numerator?
The GCF is 2X. X minus 3, X plus 3.
Right. That's a difference of squares. So we got to like do 2 steps. We got like a factor tree going there. Any questions on that. So we had two-step factoring problem. GCF, and then we had that difference of squares. Okay, how about this one, Jamie?
Would you do, two would be the number, or that you could take out?
Well, if there was a 2 in front here, we could. But since that's a 1, we can't.
Can you do something with the -8, so maybe like, positive 4 and -2, or opposite?
Yeah, which one?
Well, this is a lot of pressure.
You want -2 when you add.
My brain's going to.
You have the right two numbers, you just gotta get my signs now.
-4 and positive.
Very good. Right, -4 times positive 2 is -8, and -4 plus 2 is -2. So there's the middle one, the B. Tasha, how about this second numerator? Close. What's the square root of 16? Right. Right, good. So that's another difference of squares. So square root, the x squared for the x's and the 16 for the 4's, and remember, one's addition, one's subtraction. Okay, Cody, what about the bottom one there, the second denominator? Good, and? Good. So positive 4 times -3 is -12, and positive 4 plus -3 is positive 1. So we get it all factored now. Are there common factors? There is, right? So we need to cancel it. So we got, let's see here, an x minus 4, and then way over here is an x minus 4. As long as one's up top and one in the bottom, we can cancel. We got an x minus 3 here and one here. And then we got an x plus 4 top and bottom. We got a lot of stuff that canceled out for us. That's good, right? Makes it a little bit smaller answer. So, my answer then is 2x, x plus 3, my numerator, and just an x plus 2 for the denominator. Can't go any further. So that's simplifying and multiplying and dividing some fractions, some rational expressions. John, that one get your questions?
Yeah.
Good. Okay? Okay, so then the last two, one's addition, one's subtraction, we've got to find a common denominator, right? So remember, 1, 2, 3, 4, we factor everything we can. 5 and 6, we only try to factor what? Denominators. Right, Kennedy? Alright, so just worry about denominators when you start the addition subtraction one. So we have to have a common denominator to do the addition or subtraction. So, even though it's possible to factor that numerator, do not do it. It's not going to help you get your common denominator, right? Just concentrate on factoring this one. Difference of squares, square root of x squared, oops, is x. Square root of 25 is 5. Right? So x plus 5, x minus 5. So now I can't do anything to that binomial as far as factoring. So whatever shows up, I write down for the common denominator. So when x plus 5 showed up, I write it down. X minus 5 showed up, I write it down. I see another x plus 5, I already wrote it down, I don't need to do it again. Okay? So both sides have the x plus 5, x minus, not 2, sorry. Okay? So looking at the original fraction, there's my original denominator, and there's my common denominator. You see anything that's different? Yes or no? Nothing different, is there? No. So do I do anything different to that? No, no change. Over here I had a 3. It was x plus 5, now it's x plus 5 times x minus 5. So what did I do to that? I multiplied by x minus 5, so I have to do that same thing to the numerator. Okay, so that's what my second fraction looks like. Okay, before I can add them, what do I got to do? Nick?
Distribute the 3 and then x minus 5.
Good. Distribute the 3. Got to do this multiplication before we do this addition. Abram, what's my numerator now?
X2 minus 2x minus 2
Close.
plus 2x.
Right. -1 plus 3 is a positive 2x, right? Questions? Zach, are we done?
Factor
Yeah. The numerator, we should try to factor at this point. Now's the time to look at the numerator. Go ahead, Zach.
X plus 5, x minus 3.
Very good. Can we simplify this fraction? Yeah, we can, right? We got an x plus 5 in the top and the bottom. So my answer then is x minus 3 over x minus 5. Oops. Okay, so that one did simplify. So always check that after you add or subtract. Questions? Making sense? All right, the number 6 is just like the one we already did today. Just, different numbers, variables, same variables, I guess they were. X's. So we got x over x minus 3 and negative or minus 1 over x plus 3. And we can't factor either one, so we just write them both down for our common denominator. They showed up, we write them down. Okay, this started out as an x, this started out as a 1. What's different, or what I did to it, was multiply by x plus 3. So I'll do that to the numerator. And here, what I multiplied by was x minus 3, so I do the same thing to that numerator. Distribute. That's x squared plus 3x. And that's x minus 3. So I still have this same denominator. That didn't change. I just did my distributing so I could look at what like terms I have. Move this up a little more so we can see. Okay. Ashton, what's the numerator?
It's, put them together.
Yeah.
It's, x squared plus 2x plus 3.
Very good. It's plus 3. What's minus a negative? Plus, that's a spot. A lot of us will get in a hurry and miss that little detail. Minus a negative makes it addition. So, I should think about factoring this. Are there factors of positive 3 that add up to positive 2? No. There is not. So this one's done. Can't factor that. Numerator. All right, you have any questions about that before I just throw a couple things at you to make you think about? Okay. No questions. Good. That means you're ready to go, right? All right. What if you had this? If that was one of your numerators or denominators. What should we do? Right order. Okay, so when I put in the right order, it looks like this. I just split the two ends, right? The middle stays in the middle. How do I factor that? Liam? Yeah, take that -1 out. We don't like that negative in front of an x squared, right? So if it's in the wrong order, put it in the right order. You see a negative in front of an x squared, pull out the -1. So, negative x squared divided by -1 is positive x squared. Positive 2x divided by -1 is negative 2x. Positive 3 divided by -1 is negative 3. Can I go any further in that factoring? Yeah, go ahead, Nick.
It would be x plus 1, and then x minus 1.
Right. -3 times positive 1 equals to -3, and -3 plus 1 is -2. Be on the lookout tomorrow for a negative in front of an x squared. Who can factor that? Go ahead, Nick.
7x plus 9, and then 7x minus 9.
How'd you get those?
They're both square.
They're both perfect squares, right? So we took the square root of both. Be on the lookout tomorrow for something like that. Okay? All right, any questions? You ready? All right. That's all we got then. No homework tonight?
Oh, will there be any complex fractions?
No. I should have put one on there, but I didn't. That's all right. You guys are okay with that, right?
I'm fine with that.
That's what I thought. Jamie wanted one, but I'll just give one to her. They're gonna be 6 points apiece, so it'll be a 36-point quiz tomorrow.
So, well, yeah,